Now it's time. Marco Merlo will present.
Thank you also for the very nice opportunity to talk today, and probably I'm going to talk about a different story. This morning we got a very, very nice picture about what's going on research. We are discussing about advanced materials and let me say very, very interesting evolution, but my goal now is to talk about real life. And if you try to purchase a battery on the market, no one is going to tell you anything about that battery. We don't know even, we don't have neither, a protocol, a standard, an uniform standard that allow us to have a single, unique definition of capacity. Each manufacturer is selling you a battery. Each one is somehow free to declare such a battery, a 1 megawatt hour battery, 1.1, 1.2, 0.9, very few information. My research group is on the electrical side, so our challenge is to try to take those technologies and to adopt them in final applications, both for stationary or mobile application. So our background is on the electrical grid side, modeling electric power systems, modeling the market, trying to evaluate what does it mean to exploit a battery for performing a service to the market. What are the bounds, not just bounds related to technologies, but also bounds related to the market. So in which way we are somehow bounded to manage those batteries, not because that one is the best way for the technology, simply because that one is the way required by the market. We got a lot of connection with industry, and this is, I guess, not because we are skilled, simply because our goal is to be the interface with the market. So we are used to directly talk with regulators, regulator for the energy, to talk about, to talk with companies and to talk with manufacturer. And in our perspective, there is a lot of confusion, so we are trying to do something in such an area. We start working on this very interesting project, and in the first year, roughly, we activated 4 main cooperation, and I'm now just trying to sum up with you what we are going to do or what we already done on those cooperation. The first one is with JRC. So we started with colleagues working in research, and we take the challenge to evaluate with them in which way we can define and somehow optimize the performances of a battery energy storage system. That is a complete set, detailed, starting from the electrochemical section, moving to the BMS, to the power electronics, up to the interface with the market, taking into account also energy needs for cooling the batteries. And the point is that in literature there are a lot of works, very, very interesting. We are trying to study those techniques, and those works are for defining the performances and the characteristic of electrochemical cell. On the opposite, there is very, very few contributions related to defining the model and optimizing, consequently, defining the model of a battery energy storage system. So we worked with them. They got a 500, something like that, 500 kilowatt hour battery, and we try to develop tests and to develop protocols devoted to create a model, a reliable model of such an equipment, and we started with a very, very market-oriented approach. That is, we do know that we got 500 kilowatt hour nickel manganese cobalt batteries, just that. Just that means that data sheets are really, really minor. There are just minor information there, so we do have to develop techniques capable to create a model from samples gathered at the terminal of the batteries, of the overall battery system. The second activities is related on the market itself. That is the rule that the energy authorities are asked to develop in order to integrate those batteries in the market. Such rules could be very, very open to batteries or could bound a lot the control you can implement. For example, charging the battery and discharging the battery are two quite different activities, two different tasks. If you have the same rule, both for charging it and discharging it, probably you will be somehow limited in the operation of the system. Similarly, if you are asked to perform a service each single second, each single day of the year, each single week of the year, this kind of bound could be particularly critical for a battery system, because sooner or later you are going to hit against the limit of the state of charge. So is by definition a limited energy reservoir, and we are working in such a direction both with the Italian authority and the European one. Then moving on the electromobility, over there we also have batteries, and in this case we have the third cooperation with RSC, and this is simply because let me say the main proponer of this research path is Professor Maurizio Delfanti. He is no more, or at least he is in a very standby mode for university. He is now COE of RSC, Ricerca Sistema Elettrico Italiano, Energetico Italiano, sorry. And RSC is actually, as a matter of fact, leading the research on e-mobility in Italy, both looking at the vehicle and, moreover, looking at the interface with the grid. So we are cooperating with them in order to evaluate which kind of ancillary services the batteries could provide to the system, and services could be related in terms of vehicle to grid approach or vehicle one grid approach. That is, we can at least control the way we are charging the batteries, or in a quite optimistic approach, we can even suppose to take back energy from those batteries, the batteries of the cars. This needs a quite deep rearrangement of the rules in the market, and so we are evaluating which kind of approach could be more effective, both for the battery, for the owner of the car, but also, and this maybe is our specific goal, but also for the electric grid. And once again, on e-mobility, we are having also another cooperation with Motus-E, that is an association somehow, and on a more small scale, if you want, on specific study cases, we are trying to evaluate, for example, evaluating a park station for the cars. We are evaluating which kind of approach, which kind of control, so at the end of the day, which kind of services it is reasonable, feasible that those batteries could provide to the grid. We are taking data from real life, so we are evaluating a real park station with by far gasoline cars, and we are supposing to model, to manage not gasoline-based cars, but electric cars. So this way we are trying to evaluate how many cars are supposed to be in the park station, for how many times, what requirements could have those cars, and so on. So our goal in a nutshell is to try to manage those big data, and on top of that to create models without having a deep description, without having deep informations about the technologies themselves. So we don't have exactly which kind of electrochemistry is adopted by a battery, but we have to model the battery. So in our goal, we are trying to adopt machine learning. So the idea is, if you are not able to do something, try to adopt machine learning. In our case, the challenge is not to solve just the mathematical problem, but the challenge is to gather the data. So machine learning for modeling the market, for modeling the stochastic behavior of e-mobility and renewables, but on top of that to create realistic scenarios. The second goal we want to address, and this is what we already start implementing, is to create models for the overall battery energy storage system, so taking into account, yes, the electrochemistry modeling it in a proper way, maybe looking also to the computational effort, but also taking into account in which way power electronics is going to control the batteries and so on. And everything is market-oriented, so the final goal is to evaluate in which way these technologies could or should be integrated in the market, evaluating both the technical and economical feasibility of the approach. We are involved in a couple of European projects and in many real-life tests, and this is exactly our approach. That is, yes, to create a lot of stochastic models, but to bound those models to be really, really close to real life. Maybe we can model the scenario we have today in Italy, or the scenario we have in 5 years, because we guess that in these 5 years we have to find a solution. Thank you.